Hey, good morning. Okay. How is everyone doing? So today we'll talk about intercanister calls, which is essential on the internet computer to essentially compose different services. So right now, what you've built in for the moment, you've used one canister, but if you build a large application, you will likely use different canisters for many reasons, because first, a canister has limitations. So it can have, for example, a limitation on the memory, but it also has limitation on the number of calls that you can make per second. Whether it's query call or update calls, you have some limitation. And yeah, sometimes you have different canisters because they belong to different services. So the idea is to compose the services, kind of like on the internet today, we can call the API of YouTube or like the API of Instagram. The same thing is possible with canisters, and it's actually very easy to do, very simple, because canisters have a structured interface, and it's very easy to to use that kind of structured interface. So there is an example. It corresponds to chapter 11 of the lessons that you have in the repository. And yeah, I'll explain this example. So basically, we have a simple setup. We have two canisters. The first one is a secret canister, so it stores a password. It has like one function, get password. And we want to reveal the passwords only to users that paid. But to pay, users will use an invoice canister, which is essentially creating invoices and checking the status of those invoices. So the invoices are defined as follows. We have an invoice ID, we have invoice status, paid or unpaid, and an invoice is just an ID and a status. This is more complex in reality. Invoices are more complex. There is like an invoice canister which exists for different reasons. It's obviously way more complex, but for this example, we will keep this example very, very simple. Yeah. So the idea is that we will use the invoice canister in the secret canister. When we have a user that call the get password function, we will check first, has this user paid for the invoice? If yes, we will reveal the password. If not, we will not reveal the password. So we need to call invoice from the secret canister. And so I have the source code here. So let me zoom in a bit. Everything is here. There are different ways to call other canisters depending on if you are on the mainnet, so if you're on the internet computer, or if you have on a local replica. There are different ways. So we will start with the easiest one, which is calling actors canisters by reference. So this is in the reference folder. So this is the file that corresponds to our invoice canister. We can take a quick look. It uses two libraries that we've already seen during this week. So it uses the buffer library that you've probably used on day 1, and the results library that you've used on day 2 and 3, and even 4, I think. Basically, we have a buffer that stores the invoice. When we create a new invoice, we add it to the buffer. When we want to check the status of an invoice, we use the buffer.get method with the ID. And when we pay, we essentially check if the invoice has already been paid or if it exists. If that's the case, then we can put a new invoice. You will notice that we don't actually pay, like we don't send anything. It's just, again, it's just an example. So to pay, we just call the pay function and we assume it's good. So that's the invoice canister. And the secret canister, this is where we have the more interesting part, which is the actual intercanister call. This is a simple canister where we have a password. So the password is here, 42. It's a private password, so we cannot access it in theory from the outside. And this is where we do the intercanister call. So you notice that essentially what we do is here, we define the invoice canister, and we list all the methods that we need to call. So this is essentially like any other variable that you would define, or even a function, but this is a canister. So we are just defining it. We are saying it's an actor because canisters are actor. Remember this keyword, this is where it comes from. We specify the canister ID. So this one is not good. I think we will need to change it, but essentially assume that we have this ID somewhere. We will use it here. And then we define the interface. So the interface is the type of our canister, and the type of our canister is an actor with 3 methods: create invoice, check status, and pay invoice. So this comes from here. We just look at the method. Even I think it's even here that we have we have all those methods here. This is kind of what you're doing when you're building a canister. You have this interface, and we are just defining it here. Then in the get password method, this is where we will call our actor. So this is here. So get password, we will try to see if the user has an invoice. If it has not an invoice, we will create one. So in this case, we will do await invoice canister dot create invoice. This is how you call another canister. So as you can see, it's really easy. Basically, it's like it's like calling any other function. The only difference is that you have to await, because calling another canister is not immediate. So you need to await. If you're familiar with async await, essentially you have to wait a few seconds for the canisters to answer you. And then if there is we get the ID back, we store it locally. And in the case of we already have an ID, we essentially check the status. Again, we call the invoice canister. And if it's paid, we reveal the password. If it's not paid, we say the invoice has not been paid yet. So let me essentially deploy that and try it out. I think I'm missing one file here, so I will create it. I'm not using the playground, so this is how you would use dfx. You need this file called dfx.json. We have 2 canisters. The first one is invoice. You need to specify the main file, so this would be invoice.m, and I think type Motoko. Let me see. Why is it not correct? Yeah, okay, so that's like this. So what I've built here is dfx.json. It's the configuration file for the dfx tool that we're using. So dfx is the tool that I'm going to use to start a local replica of the internet computer. So this is like a copy locally. So that's it. We can actually take a look at the dashboard. Essentially, this gives us a few information about what's happening. So we have the version of the replica, some information about how much computation are we using. So right now 0%. And you will see that when I deploy canisters, they will be printed here. So I will do a dfx deploy, which is going to deploy those canisters. First, I will deploy the invoice canister, because I need the canister ID actually. I'm not in the good, I need to go inside this folder. So yeah, I need to be here. So I'm deploying the invoice and I will look at the canister ID so I can use it in my code for secret canisters. So this is the canister ID that we have. And we can actually take a quick look. This is what we're supposed to see. We have those three methods. And I'll take the ID here. And this is where we define. So we need to replace this with the actual ID that we really have. And now I should be able to deploy a secret canister. Again, I need to go inside this folder. So, okay, so that's it. Now we can maybe take a quick look at the dashboard to refresh. We have actually 4 canisters. So this is because, yeah, the two are like the secret and the invoice, and there is also a wallet canister that is deployed automatically, and the Candid UI that is also deployed. But those are like kind of system canisters that we don't really need to worry about. Okay, and now I can try. So what I want to do is try to call get password. So dfx canister call, maybe from the Candid UI will be actually easier to see. So get password. Your invoice has been created with ID 0. Please pay to get the password. Let's see if I try to not pay, what happens. So it's cool. Your invoice has not been paid yet. Please pay to get the password. So I need to go to this other canister, pay my invoice. So this is invoice 0. Okay, tells me that it has been paid, and now I should be able to get the password. And that's it, we have the password. Notice that this is pretty fast to actually do this intercanister call. I will explain at the end of this lecture. You have subnets on the internet computer. So this is actually how the network is divided. You have different subnets, and canisters are always in one subnet. If you are calling canisters from the same subnet, it's very fast. If you're calling a canister that is in another subnet, it can take more time, and you will have some latency due to intercanister call, but we will talk about that at the end. Do you have any questions so far about what we're doing and why intercanister call, and how does it work? No question? Is it easy? Is it easy to follow? You understand? Perfect. Okay. So let's go back to the chapter 11. So we've done the calling an actor by reference. So what I mean by reference is essentially you need to reference all the methods that you need to call. And you notice that actually when we define the invoice canister here, we don't need to list all the methods that the canister exposes. We only need to list the methods that we are going to call. So for example, here we use create invoice, check status, but we don't use pay invoice. So we could actually remove this line, and that would still actually compile, and I can show you that it would still work. Yeah, that's been deployed again with this new code. Also notice that you need to be extremely precise with the types. So you need to essentially define the types before importing the actor. Those types are defined here, and you need to essentially copy them in your code and then use them here. When we are testing your canisters on the dashboard, like the Motoko Bootcamp dashboard, we are essentially calling your interface, like some of your functions, trying out the behavior and seeing if everything works. And the main problem that I've seen so far is essentially a types issue. So you might define your type a bit differently than the examples and the instructions, and a little difference in the types. So even like if you have, for example, one more field here, or you change status to status like this, this is going to be a different object, so a different type. And this will actually make the canister crash when it calls your canister. So you would expect, for example, here, you would expect, so here, yeah, we would expect an invoice to be, are we using an invoice? No, we are not using invoice actually. We could remove this type because we are using only invoice ID and invoice status. Okay, so let's do a quick demo of what could go wrong. Let's say in invoice.mo, we define invoice status as not paid. Okay, so let me deploy invoice again. And now if I try to go and get the password, this is because I need to call it from the DFX command line because our invoices are associated with our identity and I need a new identity. So DFX canister call network call secret. So get password. Your invoice has been created. Now I will try to call again get password. What's happening here? Let me see. Invoice not found. I was not expecting this. I was expecting another issue, but not this one. So I don't know. Here we are creating it. So when we are creating it, we are putting it like this. And then we are checking, let me see. Check status. So let's see if directly here. Okay, so yeah, that was the issue I was expecting, but essentially my point here is that if you're changing the types, and you can change the types of your code, but if other people are using and calling your canister and they don't use the new types but the old types, they might run into issues because they will expect some types, and when they call the canister, it's another type. This is a critical error that will essentially crash your canister. So it won't be too bad, like your canister will recover from it, but it's called a trap. And the message that you send will essentially be destroyed. And then your canister will continue its life. But yeah, and that's what's happening a lot with the dashboard. So when you submit, sometimes you don't have the exact types that are expected, and so it trap, and you have those error message. Yeah. Can you keep the types in a type file and import same into both canisters? Yes, that's a that's a possibility. So you could have yeah, like a type folder, for example. You could create here. And you would define it as a module. So let's say invoice.types.mo. When I use when I do type file, like files that are only storing types, I like to use the name and then the types, just to remember that it's a type file. The big difference is that we are using a module and not an actor. So here, it's actor because this is defining a canister. We are listing like methods and so on. Here we will only list types. So it's a module. And you can import modules into your actor. Actually, that's what we're doing with this like base library. Those are all modules with types and functions. And so what I would do would be, for example, this. I would copy and paste it here. And then we could go here and replace. We could import invoice type like this. But you would still need to, of course, import them. So public type invoice ID would be invoice types dot invoice ID. And same with the status and same with the actual invoice. So we could remove that. And I will put that on the right. So we would have the invoice ID is imported from the invoice type. So this file dot invoice ID. So this is here, invoice status, invoice. And the good thing that we could do with this file is that we could also use it in the secret canister. So same thing, and then I would do also this. Yeah. So good question, and actually it's a good practice. The main thing is that for this to work, you need to have access to these types files. So if it's your canister that you're coding, it's really easy. If it's a canister of someone else, it can be a bit more tricky sometimes to find all the types. Is there no way to inform other callers when you have changed types? Not really. So yeah, not really. It's like a problem. So it's actually there is actually one dedicated chapter on this. I believe it's the chapter 10 or maybe 12 actually. I think it's about upgrading canister. Yes. So it's for tomorrow, but since we are talking about this, I need to mention that. So when we upgrade a canister, because we can upgrade canisters. It's a cool thing. If you're building a project and you want to add more features or fix some bugs. The problem with this is we have two main issues. The first one is memory loss. So, and we will see that tomorrow we have two types of memory in the canister, the stable memory and non-stable. And the non-stable memory, which is the one that we've been using so far, is always reset during upgrades. So that's the first issue. The second issue is the interface of our canister. If this canister is being used by other people, when we do interface changes, this can break other clients that are relying on our canister, because if we change the types, as I said, or if we remove a method and they are trying to calling it, but it doesn't exist anymore, this can break other services. And actually, that's why Candid, so this Candid like interface description language, the types that you see here are Candid, even though Candid is really close to Motoko, but Candid is a whole concept. It was created mainly because of this. What Candid enables us to do is to check a canister and say, okay, if you upgrade to this new canister, you are safe, meaning that you will not break the clients. But if you do this, you are not safe. And I can actually show you. So when we, let's say, when we upgrade a canister, there are some, so when we change the types or upgrade, there are some things that we can do, but some other things that we cannot do. So yeah, we need to change that. So it's like this. Okay. For example, one thing that we could do is add an optional parameter. So I know it will look a bit strange, but let's say message. We just want to add a message when we pay the invoice. But it's an optional message. So because it's optional, if we do a deploy of the invoice, I won't have any issue. There is no error, like there is no warning message. There is no issue. And even when I call my secret canister, so when I call, actually, wait. Yeah, we are not using the pay invoice, so it's not a good example. Maybe here I could add it. So in check status, I changed the signature function, the function signature. I changed it. So there is now two parameters, but here we are still using the old interface with only one parameter, which is ID. And you will see that it doesn't cause any issue, which can be surprising, but let me show you. So the fx canister called secret get passwords. Yeah, so I need to deploy secret again. The error that I'm seeing is because I've deployed one canister, but not the other. So there is a memory, like this canister still think there is an invoice 0, and the other one doesn't know about that. So now it should be good. Okay, so my invoice has been created, and then I can check the status. And my invoice has not been paid yet, so everything is normal. You can see that here we are using check status with only one parameter, even though the actual canister has two parameters, two arguments. But it's an optional argument. So what happened is that automatically the Candid UI, the Candid interface description language, so the language that canisters use to kind of communicate with each other, will automatically notice that and will kind of oh, there is no argument, but it's an optional one, so I will just replace with null. So it would be kind of the same as doing this. So yeah, there is no problem. But now If I don't make it optional and I try to deploy, you will see this message. So this is really, really cool because now we have this candid like verification that automatically tells me as a developer, you are making a breaking change. Other canisters or front ends may stop working because this function is not a subtype of this. I mean, this signature is not a subtype of this one. You can read about subtype in Candid documentation. It's a whole like theory of what you can do, what you cannot do when you upgrade. But we won't dive into that. Just know that basically you are warned when you do something like this. And then if I say yes, so I disregard the warning. And now if I do this, I should get an error. So the replica returned an error. So you can see it's not a normal error. It's not just my canister saying error. It's not like this or this. It's a real error in the sense that the canister crashed and even rejected the message. It says ideal error, so interface description language error, too few arguments. Too few arguments because here we only have one argument when we are actually expecting two arguments. So that's one kind of issue, but you can imagine that if you change the types, it's kind of similar. If you remove functions, if you add new parameters, like there are a lot of ways that situations can happen. Situation like this. I hope I answered your question, Hilary. So it's also about communicating as developers. We need to kind of communicate with other developers that are working with us, what changes we are doing. And if we are doing a breaking change, we really need to like inform everyone that is that they need to update their code. Okay, so we still have quite some time. So we did this part. So we called an actor by reference. There is also a way to call your actor locally. So this assume that you have the canisters defined in the fx.json, like this. We could do, you could use this syntax. So it's really, really cool. Instead of importing the canister. Well, actually, let me just get back to something with no issue. So like this. I will deploy invoice. What we could do is we could import the canister like this. So import invoice canister with this syntax. So we could kind of import a canister as a module. Oh, I think it's like this. No. Okay, so it's been a long time that I haven't imported a canister like this. So maybe I need to add it as a dependencies. Maybe like this. So this one depends on this one. And then, okay, no. Let's see. Mm, No, I think it's going to create a circular dependency, so it will not compile. Okay, so actually, it's a bit more complex than I thought. This, how to import a canister locally like this. Yeah, so I haven't done it in a long time, and I know that it's something they are kind of working on too. It's just a matter of syntax, so it's not canisters, I guess. No, it should be canister actually. I can try one last time, but I don't have too much hopes. Maybe canister. Ah, that's not here. That's here. I want to do it here. Canister alias invoice is not defined. This is usually fixed by running the fix deploy or adding dependencies. I've done both, so dependencies, and I've also done the fix deploy already, but maybe. Yeah. Okay, so I don't know. I think I know it was already kind of experimental syntax, so I think it's not sure if it's fully supported. But at some point it should be. So yeah, it's just to make things easier, but we could still use this one, this syntax, and there is no changes in how canister are called. It's just a matter of syntax, so it's not so interesting. Now there is something interesting, which is we can kind of call any canister from the mainnet as long as we have our is interface. So let's go back to our dashboard where we can see like informations about the network. We could search for canisters, and we could, assuming they have an available interface. It's not the case for all canisters, but most of them. You can actually see the interface and you can use that to call them. So let me give you an example. There is, like, for example, let's see, what would be fun? Let's see. So there is something called ICP coins, which lists all the coins of the ecosystem. So of course, in ICP token is the first one, but let's say we want to take a look at dragons. So dragons is a coin from a game that is on the internet computer. And I would like to know, so websites, I want to look for their canister ID. So they have a token, I want to find the token ID. Where can I find this? Let me think. Maybe here should be, maybe on the, so on the dashboard SNS. So it's one of those SNS. Okay. Dragon's canister. So this is all the canisters of this DAO. And they have a ledger canister, which is the canister that essentially records the transaction and keep the same ledger that you're building on day 4 for level 4. And you remember I talked about the subnet. So this is where the subnet where this canister is located. And the canister ID is this one. So if I take it and I search for it, okay, so we are already on it. We can see that we can call the methods actually. So this is like the Candid UI. We could call, let's say, the metadata, so we could get information about the token. So SNS1, the name, we could see the name. SNS1. It's the old name of this canister, but maybe symbol, total supply. We can see, like, we can get a few information. But the interesting part is this one. So we have the interface. We have access to all the methods that are accessible on this canister here. So this is everything. This is in Candid, but you also have it in Motoko. You also have it in Rust. You also have it in JavaScript and TypeScript. So you can kind of use in any kind of language. Let's say we call that, so we could use that to we could copy this. So I would copy paste this. Actually, I could just click here, and I could use so dragons.types.env, and I could copy all of this. Yes, so there is an expected token. Yeah, okay. And now what I could do is import this and use that to call this canister. So let's say, I'm not sure. So maybe we will run into some kind of issue, but let's try. So I'm importing the dragons type, and let's see. So what is one method that would be kind of interesting to call? Let's see what would be interesting. So we could have access to the balance, maybe, of our canister. Let's say we want to try that. So I will go back to secret.mo. Okay. So let dragons actor is equal to actor. So I'm using again the same like syntax. And for the type, so right now I don't know. Wait, actually I know this is the ID that I need. So this is the canister ID. And the type is gonna be this one. So here you can see that we have the type self, which essentially is like the canister itself. So we can use it. So dragons, maybe I will zoom out a bit. So dragons type dot self. Yeah, so essentially this is the type of our actor. I will create a public function, get balance of myself. So assuming like we want the balance of this canister. And we will call dragons actor. So dot ICRC1 balance of, and we need to give it an account. So maybe let's canister accounts of type accounts. So dragons type dot account. And let's have a look at what is an account. So I think it's similar to the account that you have in the day 4 and the level 4. We need an owner and a sub account. So owner is equal to I don't know, and sub account is equal to I don't know. We need the principal of our canister. So there is actually really kind of a tricky way to find that, which is I never remember the syntax actually. So what I could do is This is an old project that I was working on, so usually I take a look inside. Okay, so this is like this. So here, this, I can use it to get the principle of this canister. So like principle, there is a method which is from actor. Yeah, so principle. Actually, I don't need this. Okay, I can just, I don't need this complex syntax. I can just do actor secret, let principle canister of principle is equal principle dot from actor of secret. Okay, so I'm just getting essentially the principal ID of this canister. And then I will use it here. So I want to check principal, principal from actor secret, and sub account I will use null. And then I'll use that. So canister account. Okay, I don't know what is happening. So I think it's because of this. Yeah. Okay. And now I can do something. So I will actually deploy this canister live. So the secret canister that I built live on the playground. So I will not pay for that, but I'm deploying on the mainnet because one thing that is important to note is that you can call canisters that are on the same network. So if you have canister locally, you cannot call the canisters on the main internet computer. If you have canister on the internet computer, you cannot call local canister. So that's why I need to deploy my canister on the playground. So the playground is the real network. It's just limited, like we only have 20 minutes with this canister live. Now let's see. And I will try. I should get 0 because I believe this canister doesn't have any token, but it takes some time, as you can see. So probably this canister is not in the same subnet. As you can see, it takes like 11 seconds. And yeah, I get 0. Yeah, that's how you would call. So what we did here is we are calling this live canister, which I knew nothing about before this session. But you can essentially see all the interface and all the methods on the dashboard, and you can use that to build on top of those canisters. So here I'm just checking my balance. It's not so interesting, but you could imagine that, for example, you could have your canister could own some of those tokens, and you can transfer them, build like an exchange maybe on top of it, all sorts of possibilities. So that's what is about the chapter 11. So we're saying like, you can see all the public types used and the interface. Oops. Now maybe a quick explanation. Why are we using async await? So you have to keep in mind that intercanister call can be complex when you're using a lot of them, because actually when we do this await here, our canister could receive other messages in the meantime. So you see it took like it took around 10 seconds. I could receive other messages and process other messages. For example, someone could call those functions in the meantime, which could lead to kind of a strange situation where, as a developer, you believe, okay, someone is calling this and then waiting, and you don't really think about other things that could happen in the background. It could completely change the state of your canister, and there will be examples of that. Not today, but yeah, it could be like a major security issues. For example, you want to check the balance of someone and grant them access to something. If you don't take into account that, okay, it's not very clear, but like, yeah, take into account that basically since your canister processes message one at a time, so this is like what is on the animation here. This means that other kind of messages could happen while your canister is waiting, and that's what you can see here. So the canister A is calling canister B, and while it's answering, it also receives another message that could change its state. And then, yeah, finally, the intra versus inter subnet. So this is very complex because we actually need to go into how the internet computer works. Behind the hood, we have this concept of subnet, and there is a crossnet subnet messaging system, which essentially needs to be signed by the subnet every round by the consensus. So calling canisters outside of your subnet takes more time than calling it inside of the subnet. It's not so long, like it's a few seconds, but it's, yeah, something that you have to take into account. And usually the big applications, they use one subnet. So everything that is inside the application will be fast, but calling other applications will take a bit more time. And you can read a bit more about it. So those two sections, chapter 11, you have all the information. Cool. Any question? The function you call to the Dragon's canister, is it query function or update function? It's an update function, I believe. Wait, actually, let's see. No, it was a query function. So we can see, I call this one. It's a query function here, but it actually doesn't really matter because when you're doing intercanister call, okay, there is a concept of composite queries, so you can actually call multiple queries, but this is a very advanced topic. I will talk about that. I don't think I will talk about that this week. So when we call a query function from a canister, it's treated as an update function. So it takes as much time. Like it would not have been faster to call this one than a non-query function like this one, like approve or transfer. So in this case, it's a bit specific. Okay, so when you deploy to the IC, can you control which subnet you are deploying to? I don't think so, unfortunately. I think it was a concern that some people wanted that. I know that when so you can create other canisters from your main canister. This is like OpenChat that we will have them tomorrow, actually, they will come. So this will be like a different kind of session. It will be more, I will ask them questions and get their opinion on a few topics. And I know that they have an architecture where essentially they have a main canister, and then every time you create an account or a new chat, they create a new canister for you. And when you do that, all the canisters that are created by the main canister are in the same subnet. It's automatically like this. But I think when you're deploying your first canister, it's completely random. It's like, yeah, you can't really choose, I believe. But I think it will be the case at some point that you can choose. It's just a matter of time. Okay, so let's do quick break. We have the mentorship session in, well, 2 minutes. I will do a quick break. So I will be back in 5 minutes. And yeah, see you there. I know that some persons have already some question. See you.